In this video, we will discuss inscribed angles. An inscribed angle has a vertex on a circle and sides that contain chords of the circle. In circle C, angle QRS is an inscribed angle. So this angle here is an inscribed angle. An intercepted arc has endpoints on the sides of the inscribed angle and lies in the interior of the inscribed angle. So QS in circle C, this part here, that's our intercepted arc. It's our arc that's intercepted by angle QRS. And there are three ways that an angle can be inscribed in a circle. The first is if the center is on one of the sides of the inscribed angles. The second is the center is on the inside, so in between, inside the inscribed angle. And then the last is the center could be in the exterior of the inscribed angle. Now for each of these cases, the following theorem is going to hold true. If an inscribed angle is in a circle, the measure of the angle equals 1/2 the measure of its intercepted arc. So if we have an angle inscribed, like angle 1 here, then the angle is going to equal 1/2 of the measure of its intercepted arc. Or in other words, the arc is going to be 2 times the angle. So AB is going to be 2 times the measure of angle 1. So let's take a look at the proof of this angle theorem. If B, so we're given here, B is inscribed in circle P. So B is this angle here, inscribed in circle P. We want to prove the angle B is 1/2 the measure of AC. So 1/2 the measure of this arc right here. So what we're first going to do, we're going to draw the auxiliary line. So that's this line right here. Draw auxiliary line. 2 points determine a line. And then we can say that PB equals PC because these are both radii. So those are going to be equal. Then we can say the triangle is isosceles based on the definition of an isosceles triangle. And because it's an isosceles triangle, then our two base angles are going to be equal to each other. Then we can say that APC, so this angle right here, equals B plus C, because these are our interior angles, and we're looking at the exterior angle. So the exterior angle theorem tells us that the exterior angle is just the sum of the two interior angles. So B plus C equals angle APC, and because B and C are equal to each other, by substitution, we can say APC is just 2 times angle B. And then if we know that APC is 2 times angle B, we can say that by definition of arc measure, angle AC, so this one right here, is going to equal APC, right? So here's our arc here. APC equals AC, and AC equals 2MB. Measure of AC equals 2MB, so by substitution, we said M angle APC equals 2MB, so then we can plug in 2MB here. Angle AC equals 2MB. 2MB equals AC, so it doesn't matter which order we say it. That's our symmetric property. And then if we divide by 2, we can also say the measure of angle B is 1/2 the measure of the inscribed or intercepted arc. Let's take a look at a couple examples here. Find each measure. So we want to use inscribed angles to find measures. Measure of angle P. So in this case, we want to find the measure of this angle P, and we have the value of the intercepted arc. So we know the arc is 2 times angle P. So 2 times angle P is the measure of the arc, MN, 2 times angle P equals measure of arc MN. And then we know that MN is 70, so substitution 2 times angle P equals 70. And then if we divide by 2 on both sides, we get angle P equals 35. Now we want to find, we're going to go the other way. We want to say, what's PO? So what's our intercepted arc if we know that the inscribed angle is 56 here. So we can go the other way. 2 times the inscribed angle, so 2 times angle N equals the measure of arc PO. And then angle N, it already gives us, is 56, so 2 times 56, which equals 112, is our measure of our intercepted arc, PO. Next, we're going to say that 2 inscribed angles, so if we look here, we have 2 separate inscribed angles, C and B here. They're going, if they intercept the same arc of a circle, so they both intercept AD here. If 2 inscribed angles intercept the same arc or congruent arcs, then we can say that those 2 angles are congruent. So since B and C both intercept AD, we can say that B is equal to C. Let's apply this in an example. So we want to find the measure of angle T, and we can see that angle T and angle U both intercept the same arc SV. So if they both intercept the same arc SV, we can say that angle T equals angle U. And then by substitution, we can put in our equation here. So angle T is 3x minus 5 equals, and for angle U, we have 2x plus 15. Let's subtract 2x on both sides. To get x by itself, we have x minus 5 equals 15, and then we can move the 5 over to get x equals 20. And we want to find the measure of angle T, so if we plug in 20 for x, 3 times 20 minus 5. So 3 times 20 is 60 minus 5, we get 55 for the measure of angle T. And we could just double check. We should get the same thing if we plugged in 20 right here. And let's just double check. 2 times 20 plus 15, which is 40 plus 15 equals 55 also. So that checks out. Those two are equal to each other.